Okay. So let's do 5.3, and then we'll set some time aside to do some homework together. Okay, it's the same as before. 5.3. I believe it's called the other trig functions. Let's go ahead and cover them all at the same time. Okay. So trigonometric functions. At an angle theta, on the unit circle, so we're using that just to define the rest of the trig function. So theta is on the unit circle, and cosine would be equal to x value on the circle. Okay. Number 2. Sine of theta, sine of your angle theta, will equal to your y value. Number 3. Tangent of theta is also the same as dividing sine theta by cosine theta, which is equal to the y value over the x value. Now, as soon as you have trig functions that introduce quotients or fractions or something like that, you have the possibility of undefined values because there are a few x values that are 0, right? So when that happens, it just won't exist. Okay, so some angles are undefined. So on if they come up on the homework, like what is tan of pi over 2, for example, or tangent of 90, you would say undefined, which we'll talk about soon. Now the other 3, there's 6 trig functions, are basically just reciprocals of the originals. So the 4th one, secant theta, is equal to 1 over cosine, which is equal to 1 over the x value. So you see how it's not really a new one, it's just a reciprocal of cosine. Okay, let's flip it over. Number 5, same deal. Cosecant of theta is equal to 1 over sine theta, which is equal to 1 over the y value. And when I say x and y, I'm talking about the values on your unit circle. I hope you printed it out already. If not, please do so very soon. Number 6, cotangent will be the reciprocal of your tangent. So cosine theta over sine theta equal to x over y. I didn't write the word value, but you see it's what I implied, right? Same thing. Okay. So knowing that, you can start really almost right away doing the homework. So let's start doing some examples. So the beginning of the homework will look like this. They'll tell you, you know what? Find the 6 trig functions at a specific angle. And that angle might be too big, so you might have to reduce it and find a coterminal angle that we did last time. Remember how I said if it's over 360 or over 2 pi, subtract 2 pi or subtract 360. Okay. And I told you if you want to, you can convert to degrees if it's easier and just subtract degrees. It's up to you. So find sine theta, cosine theta, tangent theta, secant and cosecant. I guess go ahead and put cotangent. Given that theta is equal to 9 pi over 4. So the first thing I would do, because we're not all pros at radians, right? Maybe you are, huh? Yeah, it'll be blue. The first thing I would do is say, you know, what is 2 pi, right? 2 pi is about 6.28. Is 9 pi over 4 bigger than 2 pi? I don't know. Let's find out. Yes, it is. So we should subtract 2 pi. Or convert to degrees and subtract 360, because you're going to see right away that it's bigger than 360. Okay, so if you want to convert it, you can. You can do it this way if you like, but if you do it with the radians, you'll have to deal with fractions, which is not a big deal. But let's go ahead and do it both ways, just for the hell of it. Okay. So first step. Step 1. Find the coterminal angle. You know what? Let me write this better. Excuse me. Find the coterminal angle of 9 pi over 4. Okay. Since we know it's bigger than 2 pi, we will subtract by 2 pi. I know you had some of these on your homework, right? They were in radians. So all you had to do is treat them as fractions. So get your LCD of 4, right? Multiply the top and bottom by 4. This will become, oops. Let me show the step this one time. So that'll give us 9 pi over 4 minus 8 pi over 4. So that is simply pi over 4, right? 9 minus 8 is a single pi. So when you do these fractions, don't let the pi bother you. You can just ignore it. It's just product, right? It's basically we're saying 9/4 minus 2. It just happens to be a pi tagged on. It's the same deal. Don't let this mess with your head. Now, if you want to avoid this, you could convert it to degrees. If I convert this, I would have to use 180 over pi, right? My alternate. Cancel my pi's. This will get me to 9 times 180 over 4. What is 180 divided by 4? Yeah, it'd be 45 times 9, right? So now we're in degrees. What is 9 times 45? The 405? Okay, so now clearly it's bigger than 360, so subtract 360. Whoops. So take the 405 minus 360. So that will be 45 degrees, which is pi fourths. Same thing. Okay. Once you have that, just plug it into sine, cosine, tangent, etc., and use your unit circle. We go ahead and find that circle real quick. Zoom out. So let's go ahead and do this together just in case you haven't done this yet. We found the angle taken to be 45, pi over 4. So sine of pi over 4. You write down this as your answer. Cosine will be the x. Tangent will be this one divided by that, okay? Y over x. So we wrote down those. They're the same thing, so it would be a 1, right? Now, the other three were reciprocals. So we said secant, the reciprocal of, what do we say? Of cosine, right? So flip over the x value. You'll take this one for secant, flip it over. That would be your answer. You might have to do some algebra to fix the solution in a second. Cosecant, you flip that one over. And then cotangent, you'll flip over the one that whatever we got for tangent. Whatever answer that was. Okay. Does that make sense? So make sure you have this handy. So now we can answer the question. So right here, this was our first step. So step 2. Use the unit circle. To find the 6 trig functions at theta, which we found to be pi over 4 or 45 degrees. Same thing, right? So sine of 45. That's going to be square root 2 over 2, right? I don't have enough space here, so let's go ahead and put it in here. Cosine of 45 happens to be the same thing from the circle. Maybe I'll write it across instead. Cosine 45, we said is the same thing. Tangent at 45 will be the quotient of this one divided by this one. If you divide the same thing, well, that's equal to 1, right? Now, if we show the work, you would have this. Right? Nothing crazy. Now let's go ahead and do the reciprocals. Cosecant is a reciprocal of sine. So that'll be 2 over root 2. Secant of 45 will be the reciprocal of cosine. Cotangent of 45, well, the reciprocal of 1 is still 1, right? So just put the 1. But notice how we have the square root at the bottom. You may have to rationalize in the homework. I'm not sure if I'll take this. It might. I don't remember. But rationalizing is something you've done before. So this would be 2 over root 2 times square root 2 over square root 2, which is 2 square root 2 over 2, which is root 2. So these two would become just root 2. Ran out of space, I'm sorry. You see what I'm saying? Yes. Yeah, let's show this the rationalization on the next page. There's not enough space. Oh, wait a sec. Then I'll turn the page in just a moment. But so far, you see where these numbers came from. We're just reading them off the circle. That's it. You guys cool on this page? So for secant of 45, we had square root 2. No, we had 2 over square root 2, right? So in order to rationalize, you have to multiply the top and bottom by square root 2. This essentially squares the bottom for you. So 2 times root 2 is just 2 times root 2. But the bottom, square root 2 times square root 2 is a square, right? So you can think of this as becoming square root 2 squared, which cancels the radical, which then cancels this 2. Cosecant of 45 would be the same deal. It'll still be root 2. So we can just go ahead and skip the work because it's the same answer. You also think that square root 2 and square root 2 being square root 4. Square root 4 is 2. However you want to think about it, doesn't matter. That makes sense though. You remember how to rationalize? I think you did it in college algebra, and I think maybe before that too. So you've done it before. Anyway, check if they accept this one, and if not, rationalize. Any questions on this first example? Is it okay? All right. Let's do another one. This one's also from your homework. I think it's number 7 in the homework. Evaluate the following. So this one has negative angles. So we'll adjust accordingly, just like we did the big angle. Do the same thing. Sine of 3 pi over 4. B. Cosine of negative 7 pi over 4. C. There's tangent of negative 7 pi over 4. All right. So the first thing you should do is check, is it on the circle? Do I need to find a coterminal? Like these two I need to adjust because they're negative. This one maybe not, I don't know. So look at the circle. Where's my mouse? If I don't share it, it won't appear on the recording. So sorry. What was the answer to the question? 3 5 fourths, right? Okay, so that it's right here. So we don't have to, it's already a standard angle. You don't have to find coterminal, just find the answer. Sine, right? So what is sine of 3 5 fourths? Yeah, it's gonna be the y value, right here. So that's all we have to do, just write down the answer. There's no actual work to do here. It's more about, can you find the value? Let me switch back over. A will just simply be square root 2 over 2. No big deal. Part B, we got to find that coterminal first. Negative 7 pi fourths. Step 1. Find the coterminal angle. Of negative 7 pi over 4. All right, I don't know, is that less than negative 2 pi? Oops. No, it's below. So all we have to do is add a single 2 pi. So 7 pi over 4 plus 2 pi. Is your common denominator just like before? It's going to be 4, right? So negative 7 pi over 4 plus 8 pi over 4. So I essentially multiply the top and bottom by 4. I skipped a small step. Do you see how we got to here? That okay? All right, so negative 7 plus 8. Is a single pi, right? Pi over 4. Now all we have to do is do cosine of pi fourths. What is cosine of pi over 4? So use the coterminal angle in cosine. So essentially, cosine of -7 pi over 4 is equal to cosine of pi over 4. Cosine of pi over 4 is going to be right here, right? So that's it. Use that value. So the only extra step that you got to see or got to do is adjust if it's negative or too big, subtract or add, and you'll be good. Okay. We had one more, right? Was there a C or no? Yeah. Part C, since it was the same negative angle, we could just go ahead and use it. What is tangent of pi over 4?
For both, you did -7 pi. So for cosine, I think it's -3.
Yeah, both of them I think were the same.
Oh.
Yeah, it was 7,
Oh,
7 and 7. So since it's the same, I don't have to do the coterminal twice. What is tan of pi over 4? Yeah, just one. Nothing crazy, right? Okay, so let's move on to something else. I think it's question 18 in your homework. You guys pull on this page. Are there any questions on the first two examples?
tangent, it's one because everybody should pick it from where the.
It's gonna be 1 because you're dividing square root 2 over 2 by the same thing.
Oh.
So they just cancel. So when the stuff cancels, they always leave a 1. Okay, guys, cool on this page. Oh, wait a sec. No big deal. Okay. This one's 18 from the homework. I'm trying to pick one of each type. So you have a similar example. If cosine theta is equal to 10 over 26, so we don't know what the angle is, but we know that it's equal to, when you plug it in, you get 10 over 26. We also know that the angle theta is between 0 and 2 pi. So when you see that notation, theta less than equal to, or sorry, 0 less than equal to theta less than 2 pi. The way I think about it in my head is theta is ranging from 0 to 2 pi. It's somewhere in there. Right, and 0 to 2 pi means a full revolution. One period. So less than 360 degrees, bigger than 0 degrees. Same thing. So they're giving this information. Find sine theta, secant theta, tangent theta, cotangent of theta. Given that theta is in quadrant 1. So they kind of have to tell you or hint at the location of theta. They don't have to tell you the angle. They got to tell you where it's at. Because if they don't, then you won't know what sign, if these functions will be positive or negative. So the signs won't be known unless you have location. Okay. We said last time that if theta is in quadrant 1, everything is positive, right? Sine and cosine, x and y. So if it's in quadrant 2, x would be negative, which would then affect cosine, tangent, and secant. Do you see why it's important? So here it's all positive, so it's not a big deal. They want us to find the other functions. So we can use the Pythagorean identity. That says sine squared theta plus cosine squared theta is equal to 1. You can also use the formula for units, the unit circle, right? We said to use this, or you can also use this. Yeah, but we're going to stick with the Pythagorean. I think that's what they do in the book. So we have cosine. Plug in the cosine, and then solve for sine. So that's all we're doing. So first step, plug in 10 over 26. Because that is cosine, right? The formula is squaring, so you're going to square the value. $26 squared, what is that? I don't know what that is. 600 something? Gotta be 100 over, let's double check here. 26, 676. So solve for sine. So subtract that 100 over 676 over the right hand side. Then you're gonna have to square root, and then you'll have sine. Once you have sine and cosine, you can find the rest, right? They should come right out. So this is the only hard part. Subtract this over here, so you get 1 minus 100 over 676. I skipped a minor step, right? Well, I think about it in my head. If I move the term to the other side, then just swap the sign. So I moved it over. It turned into negative. Technically, we're subtracting both sides by 100 over 676. I don't care how you think about it. That is what is happening. we're gonna need a common denominator, right? To change the one. Like so. That okay? You see why that became 676? Why we have to do it? If you're rusty at fractions, let me know. Right? This is a form of one. Multiply top and bottom by 676. Now they have the common denominator. 76 minus 100. Yeah. Be 576 over 676. Just about done. We have to square root both sides. I'm gonna square root sine squared theta, but whenever you square both sides, you have to tack on the plus or minus. So sine theta is equal to, and we are going to choose positive because of the quadrant. So that's when the quadrant becomes important. So I'm choosing plus because we are in quadrant 1. Sine is positive in quadrant 1. Interesting. So when you square both of these, it turns out to be a perfect squared numbers. This is 24 over 26. We have sine. So now we can write all 6 trig functions, right? No problem. So cosine we were given, and it said it was 10 over 26. We found sine to be 24 over 26. So what is tangent? And y over x, right? So sine over cosine, divide those two fractions, and that'll be tangent. So it will be sine over cosine. So 24 over 26 divided by 10 over 26. These 26s will cancel, leaving me with 24 over 10. Technically, all these fractions reduce. I'm gonna do that later. So we have cosine, sine, and tangent. What is the reciprocal of cosine? Secant or cosecant? Okay, so we can just flip this one over and get secant. Reciprocal of sine? Split that one over. Flip the cotangent over. Okay. The homework is not going to accept fractions that are not reduced. You're gonna have to reduce all of them, which is just, it's not too bad. I think they all have a factor of two in common, right? 10/26, they're both even. It's divided by 2. Technically, this is 5/13. This guy is 12/13. 12/5. 13/5. 13/12. 5/12. Maybe I should have reduced ahead of time, but it's okay. Still worked out. Any questions on what we did? We used the formula to find sine. Once we had cosine and sine, you can find all 6. And that's what we did here. Similar to what we were doing before, we're just not using the circle. Okay, just the definition of each of each of the 6 trig functions. All right. So you guys cool on these examples we've done today so far? All right, let's spend the rest of the time doing some homework. And then if you get stumped, I can solve one up here or I can go help you out. Okay, so please pull out your computer.